Okay, so now we have a hydraulic elevator, which is a little bit different. So we're actually on the main floor, and our elevator shaft is to the left of us. This could really go anywhere, but basically this system takes hydraulic fluid and pumps it in or out of a piston inside the elevator shaft, and the pressure from the fluid pushes the piston up, which pushes the car up. You can see there's spilled hydraulic fluid in the tray. So here's the pump, and the pump has adjustments, so we can make acceleration and speed go fast up or down just by changing these, just by closing these valves. But these valves have some sensors that go to these contactors, and we can figure out the speed of the car from these contactors. So we still have contactors. A lot of the devices are now replaced with these little tiny plug-in contactors, which are much safer. I wanted to say that they're solid state, but they're not, because they got springs in them. But all the sensors and devices for the elevator come in to the back here, and they get screwed to these screw terminals, and then we've got these cards. So each of these cards controls something. Power. See, power. So this card does power. This card does the doors. This card does the car itself. This card does the sensors on the top and the bottom of the elevator. So a sensor can come in straight to a card and tell the card, oh, we got something going on. And if the card wants to activate something, let's say the card wants to open a door, it can send a signal out to, say, the door contactor here, and the door contactor will close, and that will send 24-volt power up back to the door, and that'll drive a little a DC motor in the door to open or close the door, for example. So that's what we have now. It's quite interesting. This system is fused, which is good. But if you look here, we're using a lot more power, 200 amps now. Where is it? It's a 200 amp disconnect. So, but it's more efficient because it's hydraulic. So the wiring for this pump, for this motor, is very interesting because we've got a 90 amp coil here. Oh, see, it's turning on now. Somebody pushed a button. Something clicked. Oh, I guess it didn't start. So this is a 90 amp contactor, 3 phases, 200. It's a 200, 110 to 240 volts. So one of these, so never touch these, because one of these screw terminals. This could be doors opening and closing without the car moving. But one of these terminals here has as much power as your whole house. So, and basically all this metal, so here's the pump. You'll see, we're now pumping fluid. So somebody opened the door, they got in the elevator, and the doors clicked shut. And then then somebody pushed the button, and the elevator controller told the pump to push hydraulic fluid up the piston. So as I was saying though, before I got interrupted, we've got 3 phases of power coming in. So this contactor here has a normally open, normally closed input, and so the elevator controller can send a low voltage signal to these pins here, and that closes this gate, and that sends power all the way through down into the pump. But the wiring is quite interesting because we've got power wires in here, and then we got power straight out without passing through the contactor. So then we've also got additional control wiring, and then down here we've got a Y configuration, and now we've got additional power wires on the K terminals going to the motor. So this motor has 6 wires. The reason is because we have ability to control the speed of the motor and the direction. If we're pumping in, we want the motor to turn this way. If we're pumping out, we want the motor to turn that way. So we can change the setup of the wires from a Y to a delta, and we can switch the phases here with these contactors, and that can control the speed and direction of the motor automatically. And that's done through a control wiring that comes from here and passes through some of these contactors, which actually these contactors up here are used to control the speed and direction of the motor depending on which one's open.